All right, here we go with literal equations. Example 2. Once again, this will correspond to assignment number 15 that will be uploaded to you. So we have this math expression here. It currently is solved for m, and the instructions are to solve it for n. All right? So we want to get n by itself. We want it to say n equals at the end of the process. So start at the upper left, follow the recipe. That's the best I can do for you here. Clear fractions, all right, well, yeah. So since we're dividing by this thing on the bottom here, we want to multiply both sides by 9p plus 2n. So we'll introduce that to both sides, 9p plus 2n. Remember, that's over 1. So top, bottom, cancel. Those get rid of each other. That's why we did it. That's why we introduced it, to get rid of that fraction. And this leaves 5n minus 3p over here. Now on the left-hand side, there's no canceling happening. This is just straight up distributing. So if we distribute the m to each of the terms in there, and that would be 9mp. Usually within a term, you start with the number called the coefficient, and then you put the variables in alphabetical order. And I said the alphabet real fast to myself. M precedes p, plus 2mn. So there you go, distribute. All right, and you can't combine any like terms on either side, so we're done with that. So now what? Well, the next question is the variable in one term? And let's be clear that when it references the variable, it's the one that we're supposed to isolate, the one we're solving for. And I would like to point out that as I look through here, there's 2 different terms that have n within them. And so, is the variable in one term? No! All right? No. So, what do we need to do here? We're not going to use inverse operations. Goodbye, please excuse my dear Aunt Sally. You can't do that. So what's the idea here? Well, the idea would be that we want to separate, which means we want to get the terms that have n on one side and the terms that don't on the other. When it talks about variable terms equals non-variable terms, you're talking about the variable you're solving for. You want all the terms that have n, in other words, on one side, and all the terms that don't have n on the other. So I'd look at it and say, okay, this has an n in it. I'm going to leave it over here. So, but you don't have n, so you need to go to the other side of the equation, and that would be accomplished by subtracting that 9mp to the other side of the equation. So there you go. So we've moved that over there. And so that then leaves us with 2mn equals 5n minus 3p minus 9mp. Notice none of these are like terms, so all 3 of them transfer down. Let's highlight again that these are the 2 terms that have n in them. The others don't. So again, if the goal is to get all the n's on one side, and I'm going to bring this equation up here so that we can perform the next step. And we'll backtrack, by the way, and take a look at that. There's an issue that I want to talk about here a little bit later. Oh boy, I can't wait to hear that, huh? This has n in it, this has n in it. So, shouldn't we bring this one over here and get all the n's on one side? All right. So, this becomes 2mn minus 5n equals negative 3p minus 9mp. Let's highlight again. This has n in it. I don't know if the colors are showing up very well, but oh well. This has n in it, this has n in it. This does not, this does not. There we go. We got the terms that have n on one side, the terms that don't on the other. All right, now what? Well, n is common to both of those terms, isn't it? I hope my use of the word common made you think of something. When you have 2 terms that both have a common n within them, what might you be able to do with that n there? It rhymes with factor. Oh, it is the word factor. Yeah. Couldn't we factor out an n over there on that left-hand side? Couldn't we factor out that variable? So if we factor out the n, that would leave 2m minus 5 all right? And notice the beauty of that is, instead of appearing twice, we now have n in one place, don't we? That's interesting. More to come on that. All right, now here's the thing about the other side. You know what? You could factor out a 3, you could factor out a p. You know what? We don't care. That side, we're not worried about. We're focusing on the variable n. So I guess I would just throw out there that even though you could factor the other side, there's not really a great deal of benefit in doing so. So no big deal. All right, so factor out that variable n. That's the major thing. And then I would hope you'd look at that and go, well, I want n by itself. And it's, what's going on between the n and the parentheses? Multiplication, right? So what math operation would we introduce to get rid of multiplication? Division, exactly. So if we divide by the 2m minus 5 on both sides here, that will in fact cancel the 2m minus 5. So the main point would be that at the end we can divide that, and we'll have n by itself, won't we? So, all right, this is going to be a little lazy on my part, but I'll get in trouble if I write on the wall down here again. So, you know, your final answer would be, after those cancel each other, this side would just become n, wouldn't it? And so n ends up equaling, and I'll darken that up so you can see it a little better, this expression here. Yay. All right. Now, I need to address something that I see many times. I have seen from former students, and that would be this. A lot of times, clear back here at this particular step, a person might say, well, 2m times n, I want n by itself, so why don't I just divide by 2m over here? Way back here, why'd you do all that? And those 2m's would cancel, and you'd be left with the equation n equals 5n minus 3p minus 9mp over 2m. Well, the problem with that expression is, if you're going to apply this, so I'm gonna put some scientific words to this, and I'm out of my realm, but please pretend with me. I'm a scientist. I'm not. But suppose this original formula, m represented the mass of an object, and n was neutrons, and p was protons. Don't I sound science-y, all right? But anyway, the point would be, if you wanted to calculate mass, this would be the perfect formula to do so, because it says mass equals, and you'd plug numbers in for the n and the p, the neutrons and the protons, and you'd calculate the mass. That's not what the formula is. Pretend, all right? Well, here's the problem. This formula right here, if you wanted to calculate neutrons, n, one of the values you would have to know is n. So what good would that formula do? You know, that's what they call circular logic. See, because in order to calculate n, you'd have to know the value of n. That doesn't really make any sense. Over here, if you wanted to calculate neutrons, you would plug numbers in for protons and mass, and you could do so. This makes sense. The analogy I like to use here is, when you define a word in the dictionary, when you look up a definition of a word in the dictionary, they define that word with other words, just like we defined that variable with other variables. It doesn't make sense to define a word and within the definition of that word, use that very word itself. So I hope that makes sense why we didn't do that back here, because we don't want to have that variable on both sides of the formula. Anyway, blah, blah, blah. That's example number 2. And we'll just continue our journey here with example number 3 very soon.